Welcome to our channel. In the last session, we discussed A star algorithm with an example. Now, in this session, we are moving to AO star search algorithm with an example. Here, AO specifies A represents end, O specifies R. So, what is this AO star algorithm where we are using? Generally, this AO star is a powerful best to first search algorithm. It is a powerful best to first search algorithm generally used to solve the problems that are represented by using directed acyclic graph like normal A star, that is the traditional A star algorithms explores to a single path. Traditional A star algorithm explore to single path, but this AO star algorithm explore to multiple paths. So compared to A star, AO star handles multiple paths simultaneously. So obviously it is the more efficient for solving the problem. And one more thing is the AO star algorithm is mainly designed for solving the problem that includes end or graphs. That is, it combines both the end nodes and R nodes. First of all, you need to understand what is mean by end node and what is R node. Now we will discuss. End node means assume I am at this state. These are the children's. This is one node. These are the children's. So end node means you are getting a solution for this node by summing all the solutions. That means end nodes represents where all the child nodes must be satisfied to achieve a goal. So to achieve a goal, assume if this is the end node, all the child nodes must be satisfied. So what is the cost of this node? The sum of cost of all these nodes. And R node means instead of satisfying all the child nodes, at least one child must be satisfied. At least one child must be satisfied. That is, instead of all, we are taking the minimum value. We are taking the minimum value. That is the difference between end node and R node. Anyway, this AO star algorithm uses the graph that includes both end and R. But coming to A star algorithm, that uses only R nodes. Now heuristic value, as usual, the estimation, that is, for example, we are at node n, the estimated cost from node n to goal node, that estimated is the h value. Anyway, cost to function f. So in the previous, cost to function is calculated, f is equal to G plus H. What is the G? The cost from starting node to node n. H is the cost from estimated cost from node n to goal node. Here also same, but here these values depends on either end node or R node. Either end node or R node. Now what is the algorithm? Once you understand the algorithm, and then we move to example. Algorithm is as usual, start from the root node with some heuristic value. Now expand the node. Suppose this is the root node, and expand the node. Suppose if the node is R node, if the node is R node, this has multiple childs. Now among all the childs, choose the node with minimum cost. Choose the node with minimum cost. Suppose if it is the end node, if it is the end node, and generate all the children and sum their cost. Generate all the children and sum their cost. So as usual, you are doing the cost operation, depends on whether it is end and or mark the nodes as solved if their sub problems are solved. As usual, same procedure. Continue the process until the root is solved or no expansion is possible. If the expansion is not at all possible, stop the process. This is an example. Now we will discuss this example. Here observe, this mark represents, this is end node. Here this represents R node. Okay. Now A has 3 children. If you understand carefully, either B or C plus D. So that is either B or C plus D. Now we will discuss this example in detail. Now Copy this example. Now I will explain the example step by step by using this one. What is the first step? As usual, first I will write down the function here. F of n value is equal to g of n plus h of n, just for your assumption. Now, first starting node, I assume the starting node is A. Anyway, it is in the tree format. We are starting from A. Now, A to B. One path is A to B. So, I am calculating. I am calculating from A to B. So, what are the values? G of B plus H of B. So, G of B value. Here my assumption is initially assume all edge cost is equal to 1. Initially I assumed as the edge cost is equal to 1. So, G of B value is equal to 1. Here outside the number represents the heuristic value. So, H of B value is equal to 5. 1 plus 5, 6. Now, F of A to here C comma D are end nodes. So, here you need to calculate like this. That means A to C and A to D. So, here you need to calculate like this. G of C plus H of C. These are the estimated cost from A to node C. Now G of D plus H of D. Now G of C value 1. I think my cost is 1. And what is H of C? H of C value is equal to 2. Now G of D, the edge cost by default I assumed as 1 and H of D value is equal to 4. 1 plus 2, 3 plus 1, 4, 4 plus 4, 8. Clear? 8. Now, here the value is equal to 6. Here the value is equal to 8. Now, you got the point. From A, you have two moves. Either B or C plus D. Why C plus D? Here C and D are end nodes. If there is end node, you need to calculate sum. Now, select node B. Obviously, this is the minimum cost. Now you are selecting node B. So the next step, what we are doing? Explore node B. I am exploring node B. Simply same B to E and B to F. So F of B to E, F of B to F. So here how do you write? G of E plus H of E. Similarly, G of F plus H of F. So the value is 1 plus 7. The value is 8. Here 1 plus 9. The value is 10. Now in the path B to E, which one you are selecting? Here 8 to 10. Here 1 to 8 to 8 comma 10, you are selecting the path B to E. Why? This is the path is the minimum value. This path has the minimum value. Now the thing is very simple. Here AO star algorithm mainly depends. What is the estimated cost of B? Here the estimated cost of B is equal to 5. But here after calculation, anyway I will update here. Observe A to B I am calculating. What is the value you are getting? You are getting a value 6. Update here. This is the value. And A to C plus D. What is the value you are getting? You are getting H. Now coming to B, what you are getting H, but here the value is 5. So you need to update. So H of B value is updated from 5 to 8. You got the point? After calculation of estimated cost, after calculation of estimated cost, if there is a modification, you need to update. Here this is 5 and this is 8. So update from 5 to 8. So simply strike this one and this is updated to 8. Now understand, whenever you are updating this value, obviously what happened? If you are updating in the middle value means parent to goal. Again, their value is also changed. Clear the point? That means you need to update the heuristic for A also. if you are updating the heuristic of B, you need to update the heuristic of A also. So how do you write? G of B plus, here for understanding I will write updated H of B. What is the G of B value? Anyway, the edge cost is 1 and updated value is equal to 8. So 1 plus 8 is equal to 9. Now, heuristic value is updated with the value 9. So, obviously strike out 6, again updated to 9. Whenever you are updating this one, whenever you are updating this one A to B, similarly what you need to do, A to B, at the same time you need to calculate A to C plus D. Again I will explain, understand. First I am calculating A to B and then I am calculating A to C plus D. This is the heuristic value for A to B. This is the heuristic value, that is total estimated cost from A to C plus D. After that, B is the minimum one. I select B. Now B2E is 8, B2F is 10. Now initially they given B2E for the first time. For A there is no value is given. That is the reason I updated with 6. I updated with H. Now B is the with the value H. B is with the value initially 5. Now it is updated to 8. Whenever a node is updated, obviously their parent is also updated. So I am again calculate from A to B and A to C plus D. If I am calculating A to B, the value is equal to 9. Here previously what is the value? 6. So update to 9. Suppose here if you are getting 6, no need to update. Similarly, A to C plus D. What is the A to C plus D value? As usual, A to C plus D, G of C plus H of C, G of D plus H of D. So G of C value 1 and H of C value till now not at all updated. G of T value 1, H of D value is not at all updated. So the value is equal to 8. So again you are getting 8. Why it is not updated? In this path only we are changing. In this path we are not doing any modification. Okay. Now at this step, what happened? I have the value 9 and value 8. Which you are selecting? You are selecting, after this I am moving to here, you are selecting A to C plus D. So in this, explore node C. In the next step, explore node D. First I am exploring node C. I am exploring node C. What are the children of C? C to G. Again understand, C to G R node, H plus I is the end node. So I will write down F to C G is equal to G of G plus H of G. So G of G value is 1, H of G value is equal to 3, the value is 4. Now F of C to H plus I. Why? Because H comma I are end nodes. So here G of H plus H of H plus G of I plus H of I. What are the values? 1 plus 0, 1 plus 0, the value is equal to 2. So in this step, after exploring node C, what I am getting? Here I am getting a value 4. Here I am getting a value 4. Here I am getting a value 2. Anyway, which one you are selecting? You are selecting this path, C to H plus I. C to H plus I. And one more thing, here already the heuristic values are 0. That is, these are matches with the actual cost. Okay. Now, not at all completed. We are in this, we are exploring node C only. Now you need to explore node D also. So explore node D. F of D to J. Again, what is G of J plus H of J? G of J value 1, H of J value 0. The value is 1. The value is 1. Now, whenever the value is 1, here what is the value? 4. Simply update to 1. Here previously, sir, why you are not updating previous? Here what is the C value? We are getting 4, you are getting 2. So which one is the minimum? 2. Here what is the value? 2. So same value you are getting. So no need to update. You got it? In the previous scenario, no need to update. But in this scenario, if you are calculating from D to J, you are getting a value 1. But previously the value is 4. Again, you got the point. Whenever you are updating this one, same logic. Again, calculate from A to C plus D. So, again, calculate f of A to C plus D. Here, G of C plus H of C, G of D plus H of D. What is g of c? Here g of d, h of c value is equal to 2, d of d value 1, 3, 4, 5. Now what is the cost? 5. Now f of a to c plus d. What is the previous cost? H. Now the cost is updated to 5. Now the cost is updated to 5. And anyway, all the nodes are completed. Now what is the path? What is the final path? If you observe carefully, the final path is A to C. A to C plus D. A to C plus D. In the C, what is the path? In the C, what is the path? Two possibilities are there. If you observe the diagram, from C, two possibilities, either G or H plus I. Which one has the minimum cost? Up G cost is 4, H plus I the cost is 2. Now C2, in the C we are considering H plus I plus. Why I am writing plus? From A, C is completed, end, that is the reason, plus D to J, plus D to J. This is the final path. This is the AO star algorithm. Now you got it. What the algorithm do? Simply first to calculate the heuristic values at each level, and then update the values from the leaf nodes upward to the root node at each level, from then update the value from the leaf node upward root node. So finally, if it is the end node, you are writing sum. If it is R node, you are getting minimum value. This is the final AO star algorithm. Okay, that is the end of session. Thank you.